Export to cloud. Okay. So let's start. So this is Math 140B. So my name is Matthew Chung, and this is my email. So again, instead of, if you have a question, don't type in chat. Maybe just unmute your mic and just ask me. So, okay.
Hello?
Yes?
Yeah, I'm wondering how you will be grading the completeness. I guess it's 2.5 of the total grade I see on the syllabus.
Yeah, so I'm supposed to take note of who comes to section, so I might just like screenshot the names on the screen, I guess.
Okay, thanks.
Yeah. So, but I'm just waiting for everyone to come in before I do that. Yeah. And I heard this gets recorded, so I mean, I have a list of who's here and who's not. So, okay. So, really quickly, from what I see on the website, I think homework's due on it's due Wednesdays. So I think it's best if I hold office hours maybe Monday, Wednesday, like maybe sometime before it's due. So maybe Monday, Wednesday, maybe say 2 to 3. Is everyone good with that? So, or maybe I now say by appointment if it doesn't work. So, oh, I guess no, it's not. So, so I guess it's through Zoom. I guess in this quarter, Zoom. Same ID. Yeah. So same ID as the one we're in right now. Okay. So, any questions before we start? Okay. So today your homework's on continuity. So let's go over continuity, right? So continuity at x naught. Or let me just write, maybe just for convenience, at like a point u, yeah? So there's a limit definition which says, limit x goes to u, f of x is f of u, yeah? So when we write this, a priori, we're assuming two things, right? So we're assuming one, the limit exists, right? And two, not only does it exist, the limit is the value f of u, right? So some counterexamples to one, where the limit doesn't exist is if you just take like this function, right? Like if this is 0, the limit, this is 1 and that's 2. The limit as you approach 0 from the left is 1, but the limit as you approach 0 from the right is 2, right? So the limit doesn't exist. So clearly the function can't be continuous. So, and then an example of, where the limit does exist, but, the value is not f of u is, say, if you had something like this, right? So this is, again, this is 0, 1, 2, yeah? So here the limit exists, right? The limit from the left and limit from the right, they're both 1, right? As you go to 0. But it's not the value of the function. The value of the function at 0 is 2, right? So you see here that this is the case where 1 works, but 2 fails. So, okay. So there is, there is a more concrete definition for continuity, right? Because when we say limit, what do we mean, right? Because you might say like, oh, as x gets close to u, f of x gets close to f of u, right? But the word close is not mathematically good, right? Because your definition of close might be different from another person's definition of close. So we have a precise definition of what close means. So I think the normal one is the epsilon delta. So for all epsilon greater than 0, there exists delta greater than 0, such that ST is such that if x minus u is less than delta, then f of x minus f of u is less than epsilon. So this is like the, kind of like the neighborhood definition, right? Because here, this pretty much means x is in, this ball, right? U minus delta, u plus delta, right? So you're kind of taking a ball around each point. And this is saying, f of x is within this epsilon ball, right? So pictorially, it means, so this is in the image, this is in the domain. So here, if this is u, if I take a small delta ball, right, u minus delta, u plus delta, it should, all values should lie in some y interval, right? So right here. If this is like f of u, it should lie in some epsilon ball around f of u. So that's what we mean by close, right? So this is u minus epsilon. So, and there's a, I'm sure, hopefully you remember sequences from Math 140. So there's also a sequence definition. So basically, for all sequence, let me put it this way. Basically, for all sequences xn going, so when I write this, I'm doing shorthand for limit, right? Limit n goes to infinity, xn is u, then f of xn goes to f of u. So note this has to hold for all sequences, right? So you can't just choose a particular subsequence. It has to hold for all sequences. Okay, so you might ask, why are we studying continuous functions? And the point is they are nice. So let me just, continuous functions has many good properties, right? Functions satisfy. So we're sort of getting to your homework problems right now, but satisfy like IVT and like extreme value theorem. So let's start with IVT, right? So IVT is, the idea is if I pick a point like here and a point here, let's call this B. I haven't wrote what F is, but let me just, So basically if I write any F, any continuous F, right? So if you can just draw it without lifting your hand off the board, it's continuous, right? So if it's something like this, right, you can make it as crazy as you want. But what you're going to notice is a continuous function that has these 2 points must hit every y value in between, right? Like here, if I choose any y value between f of b and f of a, then there's some value here that corresponds to it, right? So then your text calls this like C. But basically, IVT says you hit every value in between. So what this is useful for is helping you find roots, right? So that's one of your homework questions. In fact, your homework question asks you to find 3 roots. But an example would be like, let's do an easier one. Maybe show it has one, show sine x has a root, right? So basically, what does it mean to have a root? It means there's some x satisfying this equation, right? It's equal to 0. So how we do this from IVT is, well, IVT says what? If I have two points, right, I get every y value in between. So I need to show I get a y value of 0, right? I need to show I get some point on my x-axis. So one way to do this is, okay, well, how about I find the point that's below the x-axis and a point above the x-axis? Then I know I have something in between. IVT tells me I have all y values in between, right? So in particular, I have the y value 0. So note, you're going to have to choose your numbers wisely because you need for your homework, you need to choose 3 roots. But for this case, we could be as crazy as we want, right? So if this is f of x, then you just need some value that's positive, right? So you could be crazy and just do like 1,000, right? That's bigger than 0. So note that here, I mean, I don't care what sine of 1,000 is, right? Sine is bounded by 1 and -1. So this is clearly positive. And, you know, similarly, so this is where the bounds matter. So, sorry, this is cubed. This is clearly less than 0. So here, the bounds matter because IVT will say there exists C in the 2 values you plug in, right? So negative 1,000 to 1,000 such that f of c is 0. So by IVT. So what I'm saying is for your homework, right? If you have 2 roots, right here, if you don't want to choose something like, let me just I don't know how it looks like. Let's say it looks something like this, right? I mean, I guess you have a root here too, but and in fact, I think this is how your homework should look, because x cubed looks like that, right? X cubed kind of like you have an arrow pointing up and an arrow pointing down. So like if you choose a value here, right, you're gonna get a root here, but you don't want to choose like a value here, right? Because sure, you get positive and negative, but you know, you're gonna get like, you want to isolate the roots, right? You want to choose a point here to get the root right here, and then you want to choose a point here to get the root here, right? And then you choose a point there to get, you know, you need your interval small enough. But hopefully you get the idea on how to do that question. It's just three IVTs. So yeah, okay. Any questions so far? Okay. So next thing is extreme value theorem. Sorry, value theorem. So here it basically says if f is continuous on a closed bounded interval, then f is bounded. So bounded is in both ways, right? Bounded above and bounded below. And f attains its bounds. So the second part is, you know, important, right? I'm sure you've learned, maybe it's not function, but like a sequence, right? Like a sequence like 1 minus, or maybe just take 1 over n, right? This thing, the infimum is 0, right? Agree? Like, but there's no value in the sequence that's 0, right? It approaches 0, but you never hit 0. So for continuous functions, it doesn't work like that. So continuous function is nice. There's actually a value where you attain the infimum and supremum, right? So f being bounded, f is bounded means basically sup. So I guess we need a closed interval, right? So let's do AB. Sup x in AB f of x. And that's less than infinity, right? It's bounded. So, and then the infimum I'll call it little m, you know, it's bigger than, it's some number and it's bigger than like negative infinity, right? So, and not only that, right? So this is just the bounded part. So f attains its bounds means this. So it's m, but it's also f of like x naught for some x naught in a, b. And similarly for this, right? It's f of, I'll say x1 for some x1. And yeah, so there's actually a value that where you attain what the sup and the inf. So note the bounded interval is important because if I take just a non-bounded interval, let me like just take r, you know, negative infinity to infinity, even the function like y equals x squared, like one of the nicest functions, right? That has no upper bound, right? Because I mean, you can see it goes off to infinity, right? But once you close the interval, right? Once you work on a closed interval, it attains a maximum, right? The maximum is 1, right? In fact, it hits 1 at like 2 points. So the closed and bounded interval is important. So without that, continuous functions like need not be bounded, right? And obviously continuity is important, right? Because you know, if you're not continuous, you can go off to infinity, right? Like natural log is not continuous at 0. It goes off to like negative infinity. So you have to watch out for that. Okay. Any questions so far? So the first few problems of homework has you thinking, you know, like properties of continuous functions, right? Like is composition of two continuous, so on and so forth. So you should try to think of examples, and you know, if you have questions, just come to office hours. But yeah, okay. So let's go over how you would prove something's continuous, right? So example, I don't know, what should I do? F of x is continuous at x equals 4. So for this, right, let's use the, you know, epsilon delta definition. So for all epsilon greater than 0, there exists delta greater than 0 such that so here, let me go back. So remember, it's x minus c, right? So in our case, let me go all the way back really quick. So the definition here is the u in this case is 4, right? So here, I want to, this is for continuity at u, and it's f of u, right? So here, it's going to be x minus 4, right? Because I want to show it's continuous at 4. Then f of x minus f of u is less than epsilon, right? Well, f of x in this case is x squared, right? And then minus f of u, well, what's f of u? Well, f of 4 is 16, right? 4 squared is 16. So, sorry, there should be a then. So this is want to show. So hopefully I'll be using this notation a lot. The WTS, it stands for want to show. Yeah. So from here, basically the idea is you hand me some person hands you an epsilon, and you have to choose a delta such that this statement holds, right? So if you think about it, so let epsilon be greater than 0. So now it's our job. Someone handed us some epsilon. It's our job to find a delta such that this statement holds, right? So what should we choose our delta? Let's do some, you know, scratch work. So minus 16 is, I mean, there are many ways to do this, but this is, you know, x minus 4. I guess I'll write it this way. it's x minus 4, x plus 4, right? So x minus 4 we can make small, right? Because we right here we could, let me choose a different color. Right here we could choose our delta, so x minus 4 is small. So we just need to make x plus 4 small enough so it's smaller than epsilon, right? So from here, I mean, one way you could do this is, you know, x minus 4 plus 8, I guess. And then I'll use this notation for triangle inequality. So this is x minus 4 times x minus 4 plus 8, right? So now you could bound, you know, these two things, right? So ideally we're done, right? Because if I can make x minus 4 small, I can make x minus 4 squared small. So, but let's try to do this, you know, like rigorously. So the problem is right now, I think the best way is to consider two cases, right? Because if you square something, numbers below 1 and bigger than 1 behave differently, right? Because if you square a number bigger than 1, it gets bigger, right? Like 2 squared is 4. But if you square a number between 0 and 1, it gets smaller, right? Like a half squared is a fourth. So let's consider the case where the epsilon, case 1, epsilon's bigger than or equal to 1. Then you don't need to choose this 1 over 16. I just, you know, if you work it out, you'll figure it out. It works. Choose delta is this, right? So root epsilon. So here we get that x minus 4 squared plus 8x minus 4. Well, let's see what the square does. So if delta is this, right? So recall it's x minus 4 is less than delta, right? So we could choose x minus 4 smaller than 1 over 16 root epsilon. So here x minus 4 squared would be smaller than 1 over 16 squared epsilon plus 8, and then x minus 4 is less than root epsilon. Now this is smaller than just, so this is, you know, let me write equal first. So let me just simplify. So this is equal to 8 over 16 root epsilon. Now here, epsilon's bigger than 1, right? So what happens when you square root a number bigger than 1? Is it smaller than the original or bigger than the original? So like square root of 4 is 2. It's like smaller than 4, right? 2 smaller. So like if you square root a number bigger than 1, it's smaller than the original. So I could bound it above by just say epsilon. And then clearly, you know, this is smaller than epsilon, right? Because 1 over 16 squared plus this is clearly smaller than epsilon because the constant is smaller than 1. So the 1 over 16, you know, any constant will work, right? As long as in the end you get it's smaller than epsilon, which is what we want. So for case 2, yeah, epsilon smaller than 1. It's the same idea, right? So you choose, I would choose delta to be this 1 over 16 epsilon. And then here is the same idea, right? So x minus 4 squared plus minus 4 is less than or equal to. So if this is true, then I'm less than or equal to 1 over 16 squared epsilon squared plus 8 times 1 over 16 epsilon, right? So yeah, let me write equality. Let me write everything clearly first. So again, epsilon is smaller than 1. So what happens when you square something smaller than 1? It's smaller than the original, right? So again, half squared is a fourth. So this is smaller than if I just replace epsilon squared with, epsilon. And again, you get this is smaller than epsilon, right? So let me just write equal. Eight over 16. Yeah, and then you're done. So for your homework, you're gonna have to do x cubed, right? So for homework. So here, if you notice, what did I use? I used the fact that x squared minus 16 factors, right? Because you always want to relate it to your delta term, right? So when you see like x squared minus 16, you ask yourself, how can I get the thing in the blue line? How can I get x minus 4? And, for the problem above, so problem above, I use the fact that, a squared minus b squared is a minus b, a plus b, right? So for your homework, you're going to have to use the fact that, a cubed minus b cubed is, I think it's this, so correct me if I'm wrong. So something like this, right? So basically, this will give you, that'll be your delta term, right? So basically, you only need to work with, bounding this part. So kind of like, so the double underline is sort of like the x plus 4 here, right? So we had to work on how to bound that. So, okay. Any questions so far? Okay, so
Sorry, I have a question.
sure.
For an example you just talked about, can we just, x squared, can we just let delta be the minimum of 1 and epsilon over 9, and just do it from there instead of doing two cases?
Let me see. So you want to let delta be
Equal to minimum of 1 and epsilon over 9.
epsilon over 9. So I guess,
believe so, if I'm not.
I mean, as long as your calculations work. I mean, you had to do something with the x plus 4, right?
Yeah.
Yeah, I mean, this is just one way to work with the x plus 4. So, I mean, in either case, as long as you do the algebra correctly, you should be fine.
Okay.
Yeah. But the way I did it was, I mean, in this case, you could just relate x plus 4 to like x minus 4. So,
All right. Thank you.
yeah. Okay, so is everyone clear so far?
Yeah, just a quick comment. I think for the difference of the cubes, a cubed minus b cubed, the right fact, or instead of a 2, there it shouldn't be a 2.
Oh, okay. Sorry. Yeah. Thanks. I always forget that formula.
Oh yeah, same.
Yeah. Okay. So is everyone good so far? Okay. So let's continue. So you have that really hard question, right, with the rationals and irrationals. So let me just give an example of something similar. So, but before that, let me just use the fact, hopefully you all know this, right? If I have like an interval, like any interval, any open interval, right? There's like, infinitely many rationals and irrationals in here, right? Hopefully you all learned this from Math 140A. Like Q is dense, right? So, and then you can show irrationals are like, also occupy pretty much the same space. In fact, they occupy more. But yeah, so there's infinitely many rationals and irrationals in a given interval, right? So rationals is easy to see, right? Like if I give you like 0 to 1, you could clearly cook up infinitely many rationals, right? Like a half, a third, a fourth, a fifth, a sixth. That would be an example. So here we're gonna be using this fact. So, and in fact, I think you need to use it for that last question on your homework too. But let's go over an example. So let's do something similar, right? Not exactly the same. So note, just changing the problem a little changes everything, right? So basically, the idea is here, this function is called, it has a famous name, it's called the Dirichlet function. And this is a function that is discontinuous everywhere. So I think on your homework, instead of like a 1 or 0, they have like a 1 over q instead. So that actually changes a lot. It makes some part continuous and some part discontinuous. So here it's actually discontinuous everywhere. So one way to see this is let C be in R, right? And let's just consider the case where C is either rational or irrational, right? So let's say C is rational first. So we're gonna do this by contradiction. Case 1. So let me assume by contradiction, F is continuous at C. So if it's continuous, let's write out what it means, right? It's always good to write out. For epsilon greater than 0, there exists delta greater than 0 such that if x minus c is less than delta, then what? F of x minus f of c is less than epsilon, right? So given any epsilon, there should be a delta such that this holds, right? So I just need to show for one epsilon, this doesn't hold, right? Because this statement is for all epsilon, right? So if I find some epsilon such that the corresponding statement doesn't hold, we're done, right? So a good word of advice is, this is always the case, right? The how do I say it? The negation of for all is there exists, and the negation of like there exists is for all, right? So if you think of my favorite example is like if you think of for all as like the word everybody, then the opposite of everybody has hair is there exists someone without hair, right? So that is like how you should think of it. Okay. So assume this. So we're gonna let epsilon be equal to 1/2. So if it was continuous, then there exists delta such that any x satisfying this, right? Then f of x minus f of c is less than 1/2. So in our case, what is f of c? We assume c was rational. So what is f of c? You could just unmute your mic and answer.
1.
Yeah, f of c is 1, right? So this is the same as, or, right, or. But this is an issue, right? Because what does this mean? I wrote it before. This means x is in the interval c minus delta, c plus delta, right? And if you believed what I just said before, right? Given any interval, there's infinitely many rationals and irrational. There exists an irrational number. Let's call it, I don't know, x naught in such that, in this interval, right? But being in this interval means such that x naught minus c is less than delta. But then what is this then? This is f of x naught minus, but for irrationals, this is what? What's f of x naught if x naught's irrational? It's 0, right? So here it's 0 minus 1, that's 1. That's clearly not less than a half, right? So we have a contradiction. So from here, you see that, you know, and on your homework, it's a similar flavor for like proving discontinuity of that one part. And for the other part, you're still using the fact that there's, you know, you could find a rational. The reason it's like continuous, I forgot whether as irrational or rational, is because 1 over q gets arbitrarily small, right? And so basically, that's why the idea is like, yeah, the idea is like 1 over q goes to 0 as, you know, as you raise the denominator, right? So like so you'll get like it's continuous on like, I forgot, I think it's continuous at irrationals and like not continuous at rationals, but you either way you're using this property. Yeah, you want to use this property. So note that choosing it's certainly true that there exists x naught rational in this interval, right? But that's not going to help you, because if you choose a rational one, you're going to get 1 minus 1, right? And 1 minus 1 is 0, which is certainly less than a half. So it fails because there's, you know, infinitely many irrationals in this case. And similarly, I'll let you do it similarly. You know, if C is not in Q, you know, also not continuous. So in this case, you'll get, instead of 0 minus 1, you'll get 1 minus 0, right? You just repeat the proof. So in this case, you choose a rational number in that interval. But yeah, it's the same idea. So is everyone clear on this? Okay, so that's it for the notes, but wait a moment. So I have to show you the Canvas. So I posted a quiz. So I think it's in assignments. So you see, oh well, no. Okay, so I posted a practice quiz that, I mean, don't take it seriously. It's just a, you know, just 3 questions, like what's your name, something like that. But it's just so you all have practice uploading. So, and you all know how I will give the quiz. So how I'll give the quiz is I'll post the quiz 0 as assignment. So you would do it maybe like on paper, scan it, and upload it as a PDF. Now the question is, where are the quiz questions? Well, I would be uploading them on files and quizzes. So here and here, you could see the practice quiz. Now, how I will do this is I know that some of you, you know, for like example, if quiz is on Wednesday, which I think it probably will be, but if quiz is on Wednesday, right? I know that, like, you know, morning in US is like nighttime in China, right? So I don't want to, like, you know, make people wake up at like 2 in the morning to do a quiz. So I'll most likely give like a time interval. So what I'll do is maybe I'll post the quiz at like, say for example, 2 o'clock p.m. So the time I'm writing is, you know, Irvine time, like Pacific time. So, and then I'll make the assignment last until like say 12 o'clock a.m. Yeah, so you have an 8-hour interval to like do the quiz. But the quiz itself should only, I mean, it should only take you like 10, 20 minutes. So another reason for this is some students have trouble scanning, right? I mean, for some of you who are like really good at technology, you know, it's like takes like 3 seconds, right? But for some other people, it might not. So that's why I made this quiz 0, so you could practice uploading PDFs onto Canvas, and you're gonna have to do that for your homework, right? So you might as well practice from this. So my question is 2 o'clock to 12 o'clock a good time? It's like 10 hours. I guess it's 9 hours because we have discussion from like 5 to 6, but It's like 10 hours, you know, worth of quiz time. So is that good enough? Is everyone fine with that? Okay, I'll take silence as a yes. So some advice, I guess, for people who have time to do it, you know, like, I mean, I'm not gonna proctor, right? So it's like open book, open notes. So what I suggest, if you have time, try to do it without, you know, books/notes first. And then if you get stuck, then go to your notes/book. Yeah, that's if you have time. But I find this the best, right? So, you know, even if you get everything correct, take note of how long it takes you to do it, right? The quiz should only be taking you like 10, 15 minutes. So if, for example, you're taking an hour, you know, you're probably not going to finish the midterm and final. So the time it takes you to do it might also signal, you know, whether you need more practice or not. Okay, is everyone good? So that's all I have for today. So any questions? So let me read the chat. Yeah, the quiz is not graded. So you just upload. I'm not gonna check it. The one next week probably it will be graded. So this one's just practice. It's just for everyone to practice uploading PDFs. Okay. Any questions? Okay. That's all for today. I'll see you on Monday. Yeah. Great. Thank you. How do I stop recording?